with bump and specular mapping. Here we learn how to improve our initial, rather dull textures as imported from the CAD or BIM system. While many CAD and BIM systems support textures to visualize materials, they usually apply simple, plain texture maps. They are good during modeling, but are rather dull in a real-time environment. By using higher resolution textures, with complementary maps for additional material characteristics, we can highly increase the visual quality of the model. We will focus on adding some bumps to our materials first. There are many possible sources for better texture maps that are usable in an architectural context. We will illustrate the process using the Arrowway website. They specialize in real-world building textures for 3D rendering. They provide a low-resolution version of every texture under a Creative Commons license, which provides sufficient detail for real-time applications. We browse to the Edition 1 catalog and retrieve the Bricks 002 texture. We can see a preview on the page and also real-world measurements, which help us to scale the texture adequately. Download the RAR archive and unpack it. Switch back to Unity and drag or import the 3 maps into a Materials folder. Create a new material. You can do this by right-clicking in the Assets tab or from the Assets menu. Call it AW Bricks 002. By default, it uses the diffuse shader. To apply the main diffuse map, use the Bricks 002 D100 texture, as hinted by the name of the texture. Simply drag the texture onto the texture slot of the material. You can also open a browse window up by pressing the Select button. Keep the main color to white. To add bumps, we change the diffuse shader to Bumped Diffuse. This requires a separate normal map, which will be derived from the bump texture. Drags the Bricks 002 B030 texture into this slot. Unity warns us that this map is not marked as a normal map. You can press the Fix Now button to do so, or follow the manual method of selecting the texture asset and switching the texture type to Normal Map in the inspector. Derive the normal map from the grayscale image. We can adjust the settings of the map to define how extensive the bumps become. Try a low setting such as 0.05. We usually choose smooth filtering and leave the rest as default, and press Apply. Finally, to also use the specular map requires a diffuse map with a separate alpha channel. We can derive an alpha channel from the grayscale values of the diffuse image, but this is only a cheap workaround. For best results, use your image editing software to turn Bricks 002 S100 G100 into a real alpha channel. Open the diffuse image in Photoshop. Add an alpha channel and paste the grayscale specular image into this channel. Save the image with alpha channel into the PSD format, as Unity can use this directly. The best workflow when using models from CAD or BIM is actually to do this in 2 steps. First, set up the main diffuse map in your CAD or BIM software of choice and define the real-world size. This ensures it is applied correctly in the model. We illustrate this in the Material Settings dialog in Archicad, but it is very similar in SketchUp and other programs. When you now convert the model into Unity, the maps are scaled correctly upon import and can then be improved as explained earlier on. In this video lesson, we explained how we can replace a single texture with a more advanced texture set, downloaded from a dedicated site for architectural visualization. Our next video will add a sky with clouds to our scene. Welcome to the second video of section 3, where we discuss cube maps and how they are used to simulate a sky with clouds. The main background in the default scene is defined by the camera and is a plain blue color. This is not only dull, but also provides little depth or orientation. A sky can be simulated using a seamless texture that is placed on the inside of a giant cube that sits around our scene. In Unity, we can use a skybox. We first start with importing the skyboxes package from the Assets Import Package menu. These skyboxes will be installed in the Standard Assets Skyboxes folder. There are several skyboxes available in the Assets store and also in the sample assets we loaded in the previous section. Go to the Edit Render Settings menu and drag Sunny 2 Skybox onto the skybox material. The scene view immediately displays a full sky sitting around our scene. Render settings are stored inside each scene. Orbit around the scene to see the effect of the skybox in the 3D view. As it sits outside of the model, the view changes correctly when looking around, and while it is only a series of 6 images, it provides a very convincing environment. You can also press play to experience this environment in the game mode. You can define a skybox alternatively as a component for a camera. Select the main camera and add a skybox component from the Component Rendering Skybox menu. Now you can drag another skybox to the Custom Skybox parameter. To see the effect of this custom skybox, you need to play the game, as the editor will only display the skybox from the main render settings. This method can be useful when you switch between cameras in a scene as a means to toggle between different moods or environments. If we look at one of the skyboxes into detail, we can see that they are composed of 6 images that connect seamlessly at their edges, one for each view direction: up, down, left, right, and front, back. While too elaborate for this course, it is good to know that you could use any 3D rendering software to render these 6 images. Imagine how any series of images can provide your scene with a context that takes no geometry and is very quick to display. This system, however, cannot be used for animated clouds. In this video lesson, we explain the use of skyboxes as a way to add a sky with clouds around our scene. This provides a nice context for our project and improves the feeling that we are visiting an actual site. Our next video will discuss improving our glass in the scene, and we will return to our skybox images for a nice effect. In the third video, in the section on materials, we will create more convincing glass with a custom shader. Since we cannot dive into shader writing, we'll use an existing shader that does the work for us. When you imported a SketchUp or Archicad model, the glass panes received a pale, transparent, bluish material. However, this hardly looks like glass. Although actual reflections are very heavy to calculate and require a Pro license, environment reflections provide a good alternative in a real-time model, and they take little resources. First, create a new shader from the Assets Create Shader menu in the Materials folder and call it Reflective Glass. By default, this will be a very simple material using only a single texture. Open the shader with MonoDevelop. The shader code you see here was added by Unity from a template, but will replace all code with a complete shader we can download from the Unity wiki. Go to the website wiki.unity33.com, index.php, glass_shader. Go to the glass shader page on the wiki. There are 2 examples for glass shaders, but we only want the second one as this provides the best reflection effect. Simply copy the code of the shader over our default code. But leave the first line so we adapt the name we chose for our shader in Unity. We will briefly go to the shader code to get a rough understanding of what it is actually doing. If you are not into coding, you might find good alternative shaders from the asset store, which can be used as is. The first code section defines the available properties that can be set by the user. Notice that there is a cube map defined, which is used to generate fake reflections. The second section sets a few tags where Unity has warned that this shader is transparent. This is necessary so the screen drawing can reorder objects properly. First, all opaque objects are rendered and transparent materials are blended in. Luckily, we don't have to do anything to organize this. The CG program section is the actual algorithm that defines for each visible pixel on screen that refers to this shader what the color will be. For now, it suffices to know that this shader samples a color from a cube map and modulates or mixes this with the reflection color and output opacity from the alpha channel. Finally, the fallback section says what's a shader to use when the graphics adapter has no support for these particular instructions. Save the shader and switch back to Unity. The shader will be compiled in the background into GPU instructions. Before you can see the effect of the shader, it needs to be used by a material. Choose a glass material that was created when importing your CAD or BIM model and change its shader to custom reflective glass, the shader we created a few moments ago. The actual reflection effect comes from a reflection cube map. We want to use the same textures as our skybox, so create a new cube map in the Project tab and call it Sunny 2. Now we can reuse the 6 textures from the Sunny 2 skybox into the 6 texture slots of the Sunny 2 cube map. They are located in the Standard Assets, Skyboxes, Textures, Sunny 2 folder. You can drag them to the suitable slots. Also, set the face size to 128 for these textures to have some more detail. Finally, go back to the glass material and add the Sunny 2 cube map into the reflection slot. You can tweak the glass effect a bit with a brighter specular color and a darker reflection color. Final result is best experienced by orbiting around or by walking around in the scene. If you don't like to tinker with actual code, you might take a look in the asset store to find ready-to-use glass shaders. In this video lesson, we explained the use of a custom shader for an improved glass material with a reflection effect. It reuses our skybox textures from the previous video. Our next video will introduce you to the procedural shader type, using substances. Welcome to the 4th video in section 3 on materials and shaders. In this video lesson, we will use an alternative material system, which is providing a more parametric behavior. This can be used for very convincing materials with an easy control over the final look. Regular textures can be quite heavy in games and take up both disk space and memory on the GPU. Moreover, you'll need lots of them when they need to look different. Procedural materials combine embedded normal and specular maps and are defined by a series of parameters. The company Algorithmic has developed a substances system, which is supported inside Unity. There are a few free substances packages available in the asset store, and with their software you can even create your own. Go to the asset store and search for the package 18 free substances. Download and import the package into Unity. The material thumbnails you see are actual substance archive containers. While we cannot modify their inner workings without the substance software, we can adjust their parameters. Select Bricks 032 and take a look at its parameters in the inspector. We can modify parameters such as the amount, bricks in the X direction, depth, and others. To assign a substance to geometry, unfold the archive in the Project tab and drag the thumbnail icon into your object. Don't simply drag the texture, or Unity creates a new basic material from it. These textures are automatically generated from the substance material. Inspect the result in the viewport or the game. Notice you can still tweak the parameters and the material will update directly. To create a new variant from the same archive, use the plus button in the inspector. Now you can define a new look for this particular variant. For instance, choose a different basic color and assign a different seed number for another pattern. Try a few other substances and assign them to objects in your scene. We chose the Pavement 01 substance and assigned it to the ground plane. It even has an age and water level parameter for a more weathered, wet pavement look. Adjust the tiling to get a suitable scale. Some final thoughts. Substances can be very effective. They have small file sizes, yet they generate very complex and detailed textures. But they do increase the loading time of a scene, as the texture maps have to be regenerated at runtime. While you can replace the base RGB, Gloss A, and normal map with regular textures, this loses the procedural qualities and poses no real advantages over regular textures. When you need to apply your own textures, you can take a look at the Bitmap to Material package, also from Algorithmic. This allows you to generate a substance shader from your own texture map. In this video lesson, we learned about Substances, a system for procedural textures that is integrated with Unity. This gives quite spectacular results that are still easy to control. Final projects usually combine textures and substances, so try to make best use of both of them. Our next video will finish the materials section by discussing partly transparent materials. Welcome to the 5th video of the 3rd section on materials. In this final video, we will talk about the use of textures to cut out parts of a surface, to make a fence or an object with holes. When we need to create a model with holes, it takes quite a lot of geometry to model this. This will slow down the game and is not necessary in cases where a material can be used instead. By using partially transparent texture maps, we can define the opacity of a surface with only a small performance impact. We will start this section inside Photoshop to create a texture map with a few holes. Our example is a series of diagonal lines with a bevel effect to give slightly rounded edges. Ensure that you add an alpha channel 2 to contain the transparent pixels. Select the pixels by Ctrl or Command clicking on the layer thumbnail. Press copy and add a new channel in the Channels Manager and paste the channels into it. White will be opaque, black is transparent. Save this image in the Unity Project Assets folder in the PSD format. Create 2 different materials so we can compare the different shaders. For the first material, use the transparent diffuse shader and apply our picture. To correctly interpret our alpha channel to define the opaque and transparent pixels, use the alpha is transparency option. Now we have an actual transparent texture. With this technique, the edges of our fence are rather blurry and not well defined. This might be good for leaves of trees and bushes. Let's define a second material and choose Transparent, Cutout, Diffuse, using the same texture map. This gives much sharper edges, and you can control the edge with the alpha cutoff. This will be a better choice for our fence material. When you need to see the fence also from the back side of the object, you can use the transparent, cutout, soft edge unlit shader, which ensures that the fence is also seen from the inside or the back side of the geometry. For fully convincing alpha channels, there are a few additional tricks, and one of them is included in the Unity manual. The manual describes a procedure to dilate the image background, so the edges of transparent objects get a color derived from the material, which avoid bright white edge pixels, which is also referred to as ghosting. In this video lesson, we explain the use of an alpha channel in an image to control opacity in materials. We showed a regular transparent shader and 2 cutout shaders. This concludes third section on materials and shaders.